In 2019, I created a puzzle game called Hideaway Hotel. Within one of the levels, the player finds a card within a drawer. It reads, "In primary school, my child created the most wonderful work of art. It was a landscape. A luscious green hill filled the bottom third of the drawing. The hill was set against a clear blue sky. A strong oak tree stood in the middle of the hill as a sun, in the top right corner, gleamed down upon it." Later on, the player finds a portrait that they can edit. Using the information from the card earlier, the player can sort of figure out that the bottom third of the painting needs to be green, the background needs to be blue, and there needs to be an oak tree in the middle of the drawing, as well as a sun in the top right corner. Once they've completed this drawing to a certain degree of accuracy, which is shown by the percentage at the bottom of the screen, a green light will shine and the puzzle piece that they need will be released for them. In this tutorial, I'm going to show you a similar method of how to implement this sort of pixel drawing puzzle in your own Unity games. So the first thing you want to do is import a blank white tile, and I'm going to change the pixels per unit on this tile to 64 so that it fits in the 1:1 Unity ratio. Then I'm going to create a blank game object, and this is going to be our grid holder. This will hold all of our pixels and basically just manage the whole picture. Next, we're going to create a folder for our scripts, and inside this folder we're going to make a script called Grid Manager. Straight after that, we're going to make another script called Pixel Manager. Then we're going to attach our Grid Manager script onto our grid holder game object. Then we're going to open up our Grid Manager script. First, we're going to make a public game object called Pixel Object, and this is going to be our pixel prefab. We'll get rid of the update function because we won't be needing it. First, we're going to set up a function that's going to spawn our grid of pixels. To help with that, we're going to have to create a public integer called grid size, and I'm going to set that to 100, which basically means our grid's going to be 100 by 100 pixels, which might be a bit excessive, so it's up to you what you want to set that as. In our spawn grid function, we basically just want to iterate through grid size twice, once along the x-axis and once along the y-axis, and once we've done that, we want to create a new game object, instantiate it, and that will be our pixels. Then we want to create a public list of game objects called pixels, and in this we're going to store every pixel that we instantiate in our spawn grid function so that we can reference them later. And finally, we want to set up the pixels list so that it can actually accept new inputs, and we want to call the spawn grid function in our start function. If we go back to our project, we can create a new blank game object called Pixel. Add a sprite renderer component to it and set its sprite as our tile image. Next, we're going to create a folder for our prefabs, and by dragging our pixel game object into that folder, it'll tell Unity that this is a new prefab. We want to make sure that we attach our pixel manager script to our pixel, and you can update that change to the prefab by going up to overrides and clicking apply all. Then delete the pixel game object that's in our scene and drag our prefab pixel into the pixel object slot in our grid manager script. If you press play, you should see that our grid is being generated, and it's quite large and our camera's not really in the right position, so we'll need to adjust that. Now if we go and open up our Pixel Manager script, we can go ahead and get rid of update and start functions because I don't think we'll need those. We'll go ahead and create a private sprite renderer variable called srend so we can get the sprite renderer of this pixel. And we'll actually create a start function and get that information in the start function. We'll do this by typing srend equals getComponent sprite renderer. Next, you want to get the onMouseOver function ready for a little bit later. But first, I actually want to go and create some of the UI elements so that we can select specific colours for painting in our palette. For this, we'll want to create a UI canvas, and I like to set mine to scale by screen size and set the reference resolution to 1920 by 1080. Inside of that canvas, I'm going to create an image, which I'm just going to scale around and see which position of the screen that it is best appropriate to be positioned in so that it doesn't obscure any of the picture. I'm just going to create a couple more of these so that we have a variation in palette colours. Then I'll select all of them and add a button component to them. Just to keep things tidy, I'll put them all under a new game object called Paint Holder. And for each of the images, I'm going to set their image colour to a different value. For me, I'm just going to go for red, green and blue, but you can change them to whichever colours you want. So in order for this to work, we need to call a function whenever our colours are clicked. So for that we need to create one in our grid manager script. We want to make a public color variable called current color, and we're just going to set it to color.black to start with. This is where we'll store the current color that we have selected. Then we can create a public function called setPencilColor, and that's going to take in a color variable. And basically just going to take this color variable and set it to our current color variable. So if we select all of our image buttons and drag the grid holder into the slot to the left, we can check the functions that are available to us. And we can see that our setPencilColor variable isn't actually available here because Unity for some reason doesn't let you pass in color variables. So instead we're going to get the color from the image of the UI component. We need to add to the top of our script using unityengine.ui. This allows us to access UI variables. Then we simply change the color variable of setPencilColor to instead take in an image variable and set current color equals this color.color. And then we go back to the project, and for each of our buttons we select the gridmanager.setPencilColor function, ensuring that we also drag the appropriate image into the variable slot. Then I'm just going to rename all of the buttons so that they actually represent the colors that they are. Then we can return to our Pixel Manager script. We want to check for whenever the player is holding down the left mouse button. So if we type if input.getMouseButton 0, aka whenever the left mouse button is interacted with, we will get srend.color, our renderer, and we will change the color of that to whatever the grid manager has selected as our current pencil color, which we're going to get from a function. Simply, if we return to the grid manager script, we can type public color get current color, and in that function we're just going to return the current color variable. Going back to our Pixel Manager script, we can finish off that line of code by just typing get current color. So if you save everything and return to the project and press play, you'll figure out that we still can't actually paint any of the pixels. And that's because our pixel prefab doesn't actually have a collider on it. So we need to go back to our prefabs folder, select our pixel, open the prefab, and add a collider 2D to it. And I'm going to set it to be a trigger. And now when you press play, you should see that you can actually draw things on the board. The issue with this is that the system isn't entirely ideal. You may want the brush to be larger than just where your mouse pointer is. So for that we're going to have to create some sort of brush system where you can change the size of the cursor. So for this we're going to create an empty game object, and this is basically going to follow the mouse position around. We can call it mouse brush. Onto this object, add a circle collider 2D. Also add a sprite renderer component, because we'll use this to show the size of the brush. We'll create a circle sprite for it later, but for now you can actually just turn the sprite renderer component off and make sure that you set the collider to trigger. You also want to add rigid body 2D to this component so that we can actually create collisions with it. I accidentally turned simulated off on the rigid body 2D, but I will fix that later on in the video. We now want to create a new script called follow mouse. This will be for the mouse brush. So we can attach it to our brush game object and then open up the follow mouse script. We can remove the start function, and in the update function we're going to type transform.position equals camera.main.screen-to-world-point input.mousePosition. This basically converts our mouse position from a screen space vector into a world vector and assigns it to the position of our mouse brush. If we go back to our project, we can create a new tag called brush, and we'll attach that to our mouse brush game object. If we go to our Pixel Manager script, instead of using onMouseOver, we're now going to use a function called onTriggerStay2D. And in that we're going to check if the thing that we've collided with has the tag brush, and if it does, we're just going to copy and paste the code from onMouseOver and put it within those brackets. Now if we go back to our project and test this out, we'll see that it doesn't work, and that's because of the rigid body 2D component not being set to simulated, which was my mistake earlier. Make sure that you set the gravity scale of the mouse brush to 0 so that it doesn't actually move anywhere other than where you want it to go. And if you play the project, you'll see that it now works. There's a consistent issue throughout this project that if you move the mouse too fast, then your brush strokes will have large gaps between them. That's because your collider's moving too fast to actually register colliding with a lot of the pixels. This is probably largely because I've used such a massive grid of pixels. There are, I think, 10,000 pixels in this image, whereas with my earlier game example, I believe it was only a 10 by 10 grid or something like that. So that's something you will have to fix on your own, but if you use the brush normally, like a normal human being, not throwing it around the place, it will actually register a lot easier, and these gaps won't be prevalent in our larger brush size. So now I'm just going to add a few more colours to our palette and just have a quick play around to see what we can do with what we currently have. Now if we go into our follow mouse script, we're going to look into changing the brush size. So if we create two float variables at the top, one max brush size, and we'll set that to 3, and a minimum brush size, which we'll set to 1. We'll create a new function called change brush size, and we will place that in the update function. In change brush size, we're going to check to see if the player is scrolling the mouse wheel. If they're scrolling it up, then we want to check if input.getAxis mouse scroll wheel is greater than 0. That means that they have scrolled upwards. Before we forget, we also want to add another float variable at the top called current brush size. That's the size of the current brush, so that we can check it against the max and minimum sizes. Back in the change brush size function, we will, when the player scrolls upwards, change the current brush size by plus 0.5, and if they're scrolling downwards, we'll decrease current brush size by 0.5. We want to make sure that our current brush size hasn't exceeded our max brush size. If it has, then we'll just set the current brush size to the max brush size. We also want to make sure that the current brush size isn't less than our minimum brush size. If it is, then we will just set it to our minimum brush size value. And finally, we'll change the brush's transform.local scale to equal a new vector 3. Its x will be current brush size, its y will be current brush size, and the z axis on scale will be 1. I've taken this opportunity to import a circle image. It's the same size as our tile, so it's 64 by 64. I'll assign it to our mouse brush sprite renderer and ensure that the circle image in the import settings is set to 64 pixels per unit. I'm going to play around with the colour of the sprite renderer on our brush so that it is more visible during the game. And now you'll see that if you scroll up or down, it will increase the brush size and you'll be able to cover more pixels. Now I'm just going to have a quick play around to demonstrate this. I felt like our max brush size wasn't big enough, so I've decided to increase it to 10. I also thought it would be a good idea to change the colour of our mouse brush sprite renderer to a colour that isn't in our palette, so that it's always visible. Now you can see a much wider range of brush sizes, and I'm not entirely sure why I went straight for drawing a Russian flag. I think it must be some sort of subliminal messaging. But yeah, I'm just going to mess around with it a little bit further. So I've quickly created a few more colours to add to our palette. Now I want to move on to the part where we check a painting that somebody has done against another painting to see how accurate the two compare together. So if we go into our grid manager, I'm actually going to change our pixels list of game objects into a list of sprite renderers instead. This will require us to edit some of the code in Grid Manager to make sure that we're getting the sprite renderer components. And then at the top we're going to make a public list of colours called correct colours. And this is going to contain a list of pixel colours that we're going to compare our drawing against. Correct colours will be the pixel colours of the painting that we want the player to draw accurately. And we can do this by creating a public function called check colours. And inside we're going to iterate through all of the instances of our pixels, all of the sprite renderers. We're going to compare the colour of their sprite renderer against the correct colour list. If they're the same colour, then we're going to add 1 to our new integer variable amount correct. And then we're going to create a float called %, and that's just going to get the percentage amount of the pixels that are the same, and therefore how correct the interpretation of the image is. And we're just going to print that out to the console. Then we're going to create a list of colours called final colours and make another function called submit colours. In this we're going to iterate all the way through our pixels and assign the colour of its sprite renderer to its place in the final colours list. And then if we go back to the project, we're going to create a couple of buttons that we'll use to call these functions. We're going to call the first one the submit button, and the second will be called the check button. We'll attach the submit colors function to the submit button, and the check colors function to the check button. And I'll just update the text components of each of these buttons to reflect that. So now if you do a little bit of drawing and click the Save Colors button and pause the game, you'll see that in your final colors on your Grid Manager object that all of the colors of your pixels in your current painting are displayed there. And unfortunately you can't copy a list of color elements, so we're actually going to have to change something here. So temporarily we're going to go into our Grid Manager script, go down to the Submit Colors function and assign our pixels color to our correct colors list, making sure that we're instantiating the correct colors list at the top. And if we go back into our project and click play and create some sort of a drawing, once we've finished we'll click the Save Colors button, pause the game, and then go to our grid holder and copy the Grid Manager component. If we then close the game and return to our project, we can paste those values into our Grid Manager. We want to reset our pixels list size back down to 0 though, but you should see that our correct colours list is now the colours of the painting that we just completed. It's worth noting that there are other ways of doing this. You could save the data and load the data, and whilst loading the data you could assign it to the correct colours list. But now if we go back into the Grid Manager, we can comment out those two pieces of code that we added to the Submit Colors function. When we go back to the project and play the game and click the Check Colors button, it'll show that we got 0% of the photo correct. And now if I go through and try and replicate the image, you'll see that we are far closer at about 75%. And that's basically it. Now I'm going to show you a few examples of things that you could do with the project if you wanted to take it a little bit further. You could create a method for showing paintings that your players have created. By doing this, you could make a game pretty similar to Passpartout, the Starving Artist. You don't necessarily have to display your painting all at once. You could do it pixel by pixel, or you could even reveal it pixel by pixel, but in a completely random order. By revealing it very slowly, pixel by pixel, you could create a game where the players have to guess what is being revealed. Another interesting thing you could do is, instead of applying a solid colour to a pixel when your brush draws over it, you could apply the colour over time. That will add a soft gradient to your drawings. And that's everything. Thanks very much for watching.